Factoring. Factoring polynomials is a very basic algebraic skill that is used for most algebraic concepts that you may come across. Okay, so here's going to be just some basic examples and different factoring methods that can be used in order to solve problems. First, we have multiplying two binomials. Now, a binomial is an expression that has two terms, and only two terms. The most common method used to multiply those together is what's called FOIL. FOIL stands for first, outer, inner, last. If you look at this example right here, you can see that I have two binomials together, a plus b times c plus d. And in this instance, when I'm talking about first is the first terms in each binomial. So you can see that that is going to be this arrow right here. Okay, so this set, these are my firsts. Okay, so I would multiply those together, and that's going to be the first part of your FOIL. So what we're doing here is we are doing A times C. We then have to add that to the O, which is outer. The outer means your outer two terms. So it would be these right here, the outermost terms of your binomials. This is going to make up your outer piece. So here, if you notice, this is going to be A and D. So we have to add that to my A times D. Okay? So if we look at it, this was first for FOIL. This is O for my outers. Well, then we have your inners. So your innermost terms are just that. They are the two terms directly next to each other, or the innermost terms of your two binomials. Okay, that is going to make up what we call the inners. Okay, so in this instance, that's going to be b times c. So plus b times c makes up the inner. And then we have our last terms. So our last terms are going to be the last, or the outermost terms, the last terms of your function. And so those would be these right here, which are going to make up the last piece. Okay? So in this case, it's going to be b times d. So we're going to add this to b times d, and that makes last. You then are going to reduce all of these together. So there's a couple things that usually happens. This first term here is generally your squared term. Okay. Your inner and your outer, you are going to add together. This is generally the x term. This, again, is your squared term. And then, of course, your last, so this one right here is usually going to be your constant. Okay? Again, you're going to multiply them. So what does that actually look like? Well, let's look at an example. Here I have x minus 4 times x plus 7. So let's actually look at that a little bit bigger. So we have x minus 4 times x plus 7. Okay. So again, we have first, outer, inner, last. And we are going to write those apart and look at what they give you. Okay. So our first terms is just that. They are the first terms of each binomial multiplied together. So when we're talking about first, we're talking about these two right here. Notice both of these terms are x's, so here we're looking at x times x to be my first term. Okay. Then we have to do the outers. So again, the outers are going to be your outer two most terms. They're the ones that make up the ends. So in this instance, you can see that I have an x and I have a 7. So this is going to be x times 7. Then I have to add it to my innermost terms. So those are the terms that are directly next to each other, or the ones that are found at the very center of your functions. So this becomes a negative 4 times an x. And then I have to add it to the last term. So these are the last terms, okay, of your function, and in this case this becomes a negative 4 times a 7. Once you've got them all laid out, you then have to reduce. So x times x gives you x squared. X times 7 is a 7x. Negative 4 times x is minus 4x. Negative 4 times 7 is a minus 28. These right here you need to combine, so we need to add, subtract together. So this is going to be 7x minus 4x gives you 3 left over. So overall you have x squared plus 3x minus 28. And that is how you FOIL your terms together. So if you pay attention, or if you look, we have first, outer, inner, last, i.e. FOIL, which is where it gets its name. Okay? So let's look at another one. So here we've got obviously a much bigger function. So we've got 5x plus 8 times 3x minus 2. So again, we're going to FOIL. So we have first, outer, inner, last. So when we're looking at these, again, first is just that. It is your first terms of each binomial added or multiplied together. So this becomes 5x times 3x. We have to add that to your outermost terms. So those are the two on the end. Okay, so these two here. So this is going to be a 5x times a negative 2. We need to add that to my innermost terms. So these are the two terms that are right next to each other. So this becomes 8 times a 3x. And then we need to add that to your last terms, or the last terms out of each binomial. And so this becomes 8 times a negative 2. Again, now we have to actually multiply and reduce. So here, 5 times 3 is 15. X times x is x squared. So this is 15x squared. 5 times negative 2 is a negative 10x. 8 times 3 is a plus 24x. And then 8 times negative 2 is a negative 16. Again, these two middle parts have to be combined. And you're going to combine them through addition or subtraction. So you're going to add or subtract. And in this case, I have negative 10 plus 24, which is 14. So I have 15x squared plus 14x minus 16. And again, if you look really closely, we have F O I L, FOIL. Okay? So that is your examples for multiplying your binomials together, which come in handy depending on the problems you've been given. Now let's start looking at factoring. Okay. There are many ways to factor problems. So what I'm going to show you is one such method that once you get the hang of it is fairly simple. It's called bottoms up. It is a shortcut to the traditional method called the AC method. Essentially, what you're doing is you are creating the factor of which that you can turn into what you need. Okay? So, bottoms up says you have to start with what's called standard form. So this right here is standard form. And you have to use standard form because you have to be able to identify the A, B, or C functions, the coefficients that are in your problem. So A is the coefficient attached to your x squared term, B is attached to your x term, and C is essentially your constant. So the first thing you have to do is you have to multiply A times C. Okay, so that is your first step, is to multiply A times C. You then have to take that result and create all of its factors, usually by making a factor tree. That's the easiest way to approach it. But essentially, you're looking for a combination of that factor tree that is going to combine together and give you the B term. So remember, the B term is your middlemost term attached to your x value. Okay, so you have to find your factor tree of the AC part, which is going to combine and give you your B term. Remember your signs, they're incredibly important. And then you're going to do what's called setting up and completing the bottoms up step. So to set up says that your goal is to create factors that look essentially like this, where you're going to take the two terms that you found in your factor tree, i.e. the two terms that combine together and give you the B term, and that is your factor 1 and factor 2. You're going to divide each of those terms by your A term, which was your leading coefficient, and then you do the bottoms up, which says after you reduce your fractions, anything left on the bottom goes bottoms up to the top. Okay? So let's go ahead and take a look at this. So I have x squared minus 6x minus 27. So the first thing that I want to do is I want to identify A, B, and C. So this part, A is going to be the leading coefficient to your x squared term. So this is just x squared. It means A is 1. My B is going to be the coefficient attached to the x value. So in this case, it's a -6. And then C is going to be whatever your constant was. Well, in this case, it's a -27. So the first part says that you have to multiply A times C. Well, A is 1, so this is going to be 1, and I have to multiply that by C, which was -27. When I multiply that together, I get a -27 as a result. Now remember, the negative is important. So now I have to look at factors of 27 that when combined will give me 6 as a result. So there's a couple ways you can do this. One, you can create a factor tree and just list out all their factors. So that would be, say, 1 and 27. And then you've got 3 and 9. Okay. Now here I need to have a combination of these that is going to give me -6. So clearly, if you look, 1 and 27 won't work, but 9 and 3 will. and the way it's going to work to get a negative 6 tells me I have to have a positive 3 and a negative 9. Well, when I multiply 9 and 3 together, I get 27. As long as one of them is negative, I get my negative 27, which means everything is working. Okay? So this part right here is my factors that add to your B term. Okay, that's that step. So those are the factors that added to B. So the next step said that you need to actually create your factors. Okay, so here we want to create, or we want to plug in into the form x plus or minus your factor for the B term divided by A. Okay, that is the form we want to use. So I have 3 and I have negative 9. So it's going to look like x plus 3, and then remember my A term here was 1, so 3 over 1. And then I'm going to multiply that by x minus 9 over 1. So the next thing I need to do is you need to do what's called reduce the fraction. Well, here 3 over 1 becomes a 3, 9 over 1 becomes a 9. So in this case I end up with x plus 3 times x minus 9. And I have nothing else in my denominator, therefore I'm done. Okay, so there is no bottoms up to do because I don't have any denominators left. If you want to check your work, you can check yourself by foiling back out. And obviously, if you were to FOIL out these binomials, you should get back what you started with. Okay? Since there's nothing else that needs to be done, this would be your factored result. So let's look at a few more. Okay? So I have x squared plus 7x plus 12. Well, if you notice, I have a 1 again for my A term. So here, instead of looking at, say, bottoms up, one thing that you could look at doing is you could look at doing what's called reversing the FOIL method, which essentially says you're going to set things up where the first thing you know is that you have to break things into the two binomials. Now, there's a couple things or rules that you need to follow, and those are this back sign right here tells you the options you can choose from. And then the front sign, this sign right here, tells you which option you must use. So what am I talking about in terms of options? Well, there's a few things that we need to know. First of all, when you are multiplying, there's a couple rules to follow. If you start out with a positive term and you multiply that by a positive term, you get a positive as a result. If you start out with a positive term and you multiply by a negative term, you get a negative as a result. However, if you start with a negative and you multiply with another negative, you get a positive result. So this back term here tells you the options to choose from. So notice my back term here is positive. A positive tells me I have two options to choose from, and those options would be this first one, because I get a positive result, or the bottom one, because I get a positive result. The middle one, or the middle term here, tells you which option you have to use. In other words, it tells me which option I have to work from to get my result. Okay? So when we're looking at them, I have to know which option is going to, when I add them together, is going to give me a positive. Well, obviously, if I add two negatives together, chances are I'm still negative, which means the only option that I can choose is I have to have both factors positive. Once you have figured out what your signs have to be, you then have to remember FOIL said my first terms were going to be the squared terms. So I have x squared, so I have to break it. What times what gives me x squared? Well, that's x and x. And then I have to look at my factors of 12 that give me 7. So I can use a factor tree. I'm looking at 12. Remember, my 12 was positive, so all my factors are positive. My middle term is positive, so all my factors are positive. And so here my factors of 12 would be 1 and 12, 2 and 6, 3 and 4. So I need to know which one of these, when added together, is going to give me 7. So if I look at 1 plus 12, this gives me 13. If I look at 2 plus 6, that gives me 8. However, 3 plus 4 gives me 7. That tells me that these were the factors I need to use. So this is going to be 3 and 4. So that is the reverse FOIL method. It's just another way of looking at factoring if you don't want to use the bottoms-up method to work your problem. Okay. So let's look at another one. So here again, my A term is 1, so I could use that reverse FOIL method if I wanted. Again, remember the back term tells you the options to pick. So if I look at that, I have to multiply to a positive. So I've got positive times positive gives me a positive result, or negative times negative gives me a positive result. And then this middle term here tells me which option to use. Well, I have to add it to a negative, which means the only option possible is negative and negative. So when I go to set up my binomials, I know I have to have two binomials, and I know my terms or my operations have to be negative and negative. So I have y squared. I have to break it. This becomes y times y. And then I need factors of 24 that are going to give me 14. Again, I can list out my factors. So I know I have a 24, and my 24 was positive, but both of my factors have to be negative. So I've got a negative 1 and a negative 24. I have a negative 2 and a negative 12. I've got a negative 3 and a negative 8, negative 4 and negative 6. So again, I have to figure out which combination of these, when added together, okay, is going to give me the value I wanted. So negative 1 minus 24, or plus a negative 24, gives you negative 25. Negative 2 plus negative 12 gives you a negative 14. That is actually what I wanted, which means I can stop, because this is going to be the only set that is going to work. So here, this is going to give me 2 and 12. Again, I can FOIL them back together, and I should get what I started with. Let's look at one more. Again, we can use reversing that FOIL idea. And the only reason why we're doing this easily is because the coefficient attached to your n squared value is 1. If that coefficient is greater than 1, then chances are the fastest thing to do is going to be to go ahead and use, say, that AC bottoms up method. Okay. Now, this one's going to be a little bit different. So here, the option to pick from is kind of limited. And the reason for that is because there is only one combination that when multiplied together gives me a negative. And that is if I have one positive and one negative, gives me a negative result. Therefore, because I don't have a secondary case to choose from or a different option to pick from, it doesn't matter what the middle term is. The middle term will matter once we actually get into it. So because I only have the one option, it means automatically I know that my two binomials are going to have one positive and one negative. Now my term is an n, so I need to break the n squared into n and n. And now I have this 72. So I need to look at my values of 72 that when combined are going to give me a negative 1. So I have 1 and 72. Okay. And now you can list them all, or you can just simply list the ones that you think are going to work. It's totally up to you what you feel like doing. I'll go ahead and list them all just so you can see them. So we have 2 and 36. We have 3 and 24. We have 4 and 18. We've got 6 and 12, and then 8 and 9. Okay. So here's the rule that you need to follow. If the middle term is negative, then the bigger factor is negative. Okay. So again, if the middle b term is negative, then the larger factor is negative. The opposite is true for positive. Okay? If the middle term was positive, then the larger factor would be positive. Now for our intensive purposes, our middle term is negative, which means our bigger factor has to be negative. Therefore, if you notice down on this left hand or this right hand side, these are all of the bigger terms, so these all have to be negative, which means the left hand side are all of my positives. So if you look closely, you can see that there is only one example that is actually going to work for this problem, and that is going to be my bottom example here, which says positive 8 and negative 9. So this becomes a positive 8 and a negative 9. So if you see, if we actually combine these together, you get a negative 1 as a result, which is what we wanted. Okay. Now let's look at an example here where you can see that your a term is a value greater than 1. So since this term is greater than 1, then for this one I would use that AC method. So that AC bottoms up method says I need to do a times c. Well, I need to know what a is. So again, if we look, a is going to be the x squared term. Well, it's the coefficient attached to it, so a is 6. B is going to be the coefficient attached to the x term, which is 17. And C is going to be your constant, which is 5. So here, A is 6, so this becomes 6 times C, which was 5. 6 times 5 is 30. Since both 6 and 5 are positive, we are looking at a positive 30. And now I need to know factors of 30 that when added or subtracted will give me a 17. So I have 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay. So if I look, I need to have two factors that when added together are going to give me 17. Well, the only combination I have that's going to do that is going to be 2 and 5. And these both have to be positive. 2 plus 15 gives you 17. So here, if you remember, this step here are my factors that add to your b term. And in this case, b was a positive 17. Once you figure that out, remember you have to start with your method. So we are looking at x plus or minus your factor over the a term. Okay? So we have to go ahead and plug it in. My factors are going to be 2 and 15. So this is x plus 2. Remember your a was 6, so this is 2 over 6 times x plus 15 over 6. Once you do that, remember you need to reduce the fractions. So if I look, this is going to be x plus 2 over 6 is going to reduce to 1 over 3. And then this is x plus 15 over 6 is going to reduce to 5 over 2. Now, if you see, I still have a denominator. Because I have denominators, this is where bottoms up comes from. Okay? Bottoms up says the denominator, or the bottom, flips up to the x term. Okay? So this term right here, the 3 part, is going to flip up and become partnered with the x. Here, my 2 is going to flip up and become partnered with its x. So that means this factor is going to become 3x plus 1 times 2x plus 5. Now again, if you wanted to check yourself, you could FOIL this back out and you should get exactly what you started with. Okay? So let's try it again. Here, my a term is 3, my b term is 7, my c term is a negative 6. Again, we start with a times c. My a was 3, my c was a negative 6, gives me a negative 18 as a result. Now I need factors that are going to give me a positive 7. So I have 1 and 18, 2 and 9, 3 and 6. That's what I'm looking at. And I need a combination of these that when added together gives me 7. Well, obviously 1 and 18 is out, and so is 3 and 6. The only ones left are 2 and 9. Since I want my 7 to be positive, it means the bigger factor is positive. Therefore, this means -2, positive 9, and these were the factors I'm looking for. So again, I need to create my factor. So I am creating x plus or minus that factor over the a term. So in this instance, I have x minus 2 over 3, and then I have x plus 9 over 3. Well, the next step, if you remember, is reduce. If you look at this first fraction, there is nothing to reduce, so this is still going to be x minus 2 over 3. And then over here, 9 over 3 reduces to 3. So here this becomes x plus 3. The last thing we have to do is bottoms up. So here in my first fraction, I have a bottom of 3. I have to shift that up to become partnered with my x term, leaving me with 3x minus 2 times x plus 3. And those would be those factors for that problem. Okay. Okay, let's look at 2 last examples. By this time, hopefully you were feeling fairly confident, or at least somewhat confident in the questions you might have, but let's just do it again real quick. Again, I have a coefficient out in front that is greater than 1, so I'm going to go ahead and use that AC method. So here a is 6, b is -19, c is 10. So I first have to do a times c. So this is 6 times 10, which gives me a positive 60. So again, I can look at my factors. I need to have factors that give me a -19. So it just so happens that I know 4 and 15 would combine. And since I have to have a negative, both of my factors have to be negative. So to start things out, again, x plus or minus your factor over a. So here this is going to be x minus 4 over 6 times x minus 15 over 6. Reduce your fractions. This is x minus, I can divide top and bottom by 2, so this becomes 2 over 3. And I have x minus, I can divide top and bottom here by 3, so this becomes 5 over 2. Again, I need to do bottoms up. Bottoms up says your denominator is going to flip up into your x. You can kind of think of it as like you're taking a shot, right? Bottoms up, take a shot. So here we have 3x minus 2 times a 2x minus 5. Again, FOIL that together and you should get what you started with. Okay? Last but not least, I have 9x squared minus 3x plus 20. Again, my a term is greater than 1, so I would use the AC bottoms up method. My a is 9, my b is -3, and my c is -20. Start out by doing a times c, so 9 times a -20. gives you negative 180. I need a combination of 180 that is going to give me negative 3. To speed things up, I know a combination of 12 and 15 should work. Because I want 3 to be negative, it means the bigger factor has to be negative. This leaves me with a positive 12 and a negative 15. So again, I want to set up x plus or minus my factor over a. So in this case, I'm going to have x plus 12 over 9 times x minus 15 over 9. I have to reduce my fractions. So here 12 over 9, I can divide them both by 3. So this becomes x plus 4 over 3 and x minus 5 over 3. Again, I need to bottoms up. So the denominator here is going to bottoms up or take its shot up to the top. And so here we become 3x plus 4 times a 3x minus 5. So that's kind of everything you would need to know about factoring in a nutshell using either the reverse FOIL method or the bottoms up method. So happy factoring, and see you next time.